Okay, in this video we're going to take a look at the sum formula for tangent. I have a confession to make. I do not have that memorized because I don't need to. Because I know that tangent is sine over cosine, and I know the sum formulas for sine and cosine. Now, if I were using the sum formula for tangent a lot, it might be worth my while to memorize it, or I might just use it so often that I accidentally memorized it. But I don't use it that much, so I'm going to just derive it. Tangent of a plus b is sine of a plus b over cosine of a plus b. But now I know those two formulas. So sines, remember those are the ones I think of as social. So that's going to be sine a cosine b plus cosine a sine b. Cosines, they stick with their own kind. Cosine a cosine b minus sine a sine b. So right there, that is a formula for tangent of a plus b. Now, that's not the version that you're going to see in your textbook or that you'll see in most math textbooks, because generally when we're talking about tangents, people find it helpful to have this written in terms of tangents as well. Okay, so this is correct, but it's not the standard version that gets used. What I want to do is see if I can't write this in terms of tangents instead of sines and cosines. To do that, I'm going to remember that tangent is sine over cosine, so it has cosines in the denominator. So I'm going to multiply this whole thing by a very fancy form of 1. I'm going to multiply by the reciprocal of cosine A cosine B. Now, that's something over itself, so I'm just multiplying by 1, but that's going to introduce a factor of cosine of A and cosine of B in the denominator of each term. Now on top, I need to distribute that to both terms. So this is going to become sine A cosine B over cosine A cosine B. Just distributing that to this piece. Plus, now I've got this one, cosine A sine B over cosine A cosine B. And then on bottom, I've got to distribute. So I'm going to have cosine A cosine B over cosine A cosine B minus, now this piece, sine A sine B over cosine A cosine B. Now it looks like I've just made this atrocious, but it actually simplifies down quite nicely. Notice in this first term I can cancel the cosines of B. I've got sine A over cosine A, that's tangent of A. Here, I can cancel the cosines of A. I've got sine B over cosine B. That's actually tangent of B. Here, I can cancel cosine of A and cosine of B. Remember, when you're canceling, if everything cancels out, you're left with a place holding 1. Okay. And then here, nothing cancels, but notice I've got a sine A over a cosine A and a sine B over a cosine B. So this is minus tangent of A times tangent of B. That is the standard version that you will see for tangent of A plus B. Okay. All right, so let me just copy that down up here so I can clear some more space. So tangent of A plus tangent of B all over 1 minus tan A tan B. And I'll probably memorize that for the next week or so while we're talking about it, and then I'll forget it again and derive it the next time I need it. Okay, so that is the sum formula for tangent. The difference formula for tangent is going to be very, very similar. So what I want you to do is pause the video and derive for me the formula for tangent of A minus B, doing exactly what we just did for the sum formula. You're going to write it as sine of A minus B over cosine of A minus B, write out the difference formulas for sine and for cosine, and then multiply by the appropriate form of 1 to get it in terms of tangents. Okay, so pause the video, come back in a moment. Welcome back. All right. So hopefully this is what you did while the video was paused. Sine of a minus b over cosine of a minus b. And it's going to be so similar to what we just did because these difference formulas, remember, are just the same as the sum formulas except the sign in the middle is changed. So sine of a minus b is sine a cosine b minus cosine a sine b. And cosine of a minus b is cosine a cosine b plus sine a sine b. Okay, so that's just applying the difference formulas for sine and cosine. I used the shortcut that they're the same as the sum formulas, but with the sign between the terms reversed, although you can always derive it by rewriting it as sine of a plus the opposite of b. Now I want to get this in terms of tangents, so once again I'm going to multiply by 1 in the form of the reciprocal of cosine a cosine b over itself. So when I distribute this out, I'm going to get sine a cosine b over cosine a cosine b minus cosine a sine b over cosine a cosine b over cosine a cosine b over cosine a cosine b plus sine a sine b over cosine a cosine b. Here the cosines of b cancel. Sine a over cosine a is tangent of a. Minus, here the cosines of a cancel. Sine b over cosine b is tangent of b. Over, here everything cancels, so I'm left with a 1 plus sine a over cosine a times sine b over cosine b, that's just tangent of a times tangent of b. So now I've got a formula for tangent, and now that I have some formulas for sine, cosine, and tangent, I basically have them for everything because secant is just the reciprocal of cosine, so I would just take the reciprocal of the sum formula for cosine to get the sum formula for secant. Same thing for cosecant and sine, and same thing for cotangent and tangent. Okay, so I can actually work with any of them, which is kind of nice. In the next video, we'll get a little bit of practice just using one of these formulas for tangent.